For each of the following equations, find the derivative with respect to x. Okay, we can do that. When they say derivative with respect to x, that's what you write as d dx. And what it means is, it's two different pieces. The d means take the derivative of the thing you've got, and this means then divide it all by dx. So you're going to get a derivative like dy dx and that sort of thing. It's possible later we'll do derivatives with respect to time, and we'll write them d dt. You'll be dividing everything in those expressions by dt, and that'll tell you how fast certain variables are changing in time. You could do a derivative with respect to a, and you'd write it ddA. And you'd take the derivative of the entire expression and then divide every single term by dA when you were done. So when you see that notation now, you know what it's talking about. For now, we're using dx, which is what we're kind of used to anyway. And let's see if I can fit all three of these onto one screen. The derivative here for 4x squared is going to be 8x what? dx. Because you're not done with the term until a d is popped out, generally. And 4y squared gives you 8y dy. And the derivative of 20, this is one of the exceptions. Since there is no variable, the derivative is simply 0. We're saying that 20 does not change ever any amount, so its rate of change is 0. We want this with respect to x, so we divide every term by dx. And the dx's cancel out. And we get to 8x plus 8y dy dx equals 0. If we solve that for dy dx, we take the 8x to the other side to get 8y dy dx equals negative 8x. Then we divide both sides by 8y. And victory is ours. This is originally minus 8x over 8y. I divided by 8 on the fly because I'm trying to conserve space. All right. B, here we have product rule because we have x times y. Two different variables is always product rule. And the product rule says to do first d second, which would be 2y dy. So first d second plus second d first plus the derivative of 2y is 2 dy, and the derivative of 3x is 3 dx. Okay. Now, derivative with respect to x, we divide every single term by dx. And if you anticipate this step, then you'll end up doing these the way the workbook shows them, where dx just never gets written because you know it's going to cancel out. So the book just doesn't write these in the first place. And whenever there's a dy, you automatically put it over dx because you know that division's coming. So there's that line. We want our dy dx's isolated, so I want to get all the terms containing dy dx to the left side. They're already there. And all the terms that don't contain dy dx are going to get thrown over to the right side. That gets us, oops, sorry, I'll combine that a little better. In this term, we have 4 times 2 is 8xy dy dx. And then we have 2 dy dx equals, the 4y squared goes to the other side, becomes negative, and we also have 3 hanging around there. All right. 2 different instances of dy dx, not good, but we can fix it by factoring. Since they both contain dy dx, it's a common factor. You can pull it out, and that leaves you with 8xy plus 2 equals la. And now to isolate dy dx, we divide both sides by 8xy plus 2. Minus 4y squared plus 3 divided by what was on the left-hand side. I don't see anything we could simplify about this, so that would be our finished derivative. And let's see if, oh, C is going to involve quotient rule, and I don't like my chances of fitting all of that into the remaining space, so I'm going to create a separate link for C. So see you in a minute.